Square root. So we can see what's the definition of a square root. It basically, we are interested in positive numbers and we are finding the square root of a positive number. For example, if someone asks us what is the square root of 1, so we are searching for numbers whether there exists a root 1 that is equal to some number. Basically, we are interested in finding numbers if a number which is multiplied by itself gives a square number. So that's a square number. So 1 multiplied with 1, which is 1. If I multiply 2 with 2, we have 4. If I multiply 3 with 3, we have 9. If I multiply with 4, we have 16. So and so on and so forth. So if someone asks us what's the square root of 3, does there exist any positive number such that the square root of the number multiplied with itself gives us 3? No, we don't have such a number. So similarly, we can go for the definition. The square root of a number is that number which when multiplied by itself gives us the product. So b square is equal to a, which implies b is equal to root a. So basically, this is the notation for square root. We are using this as a notation. And next one, what is square root of 9? It is 3. So does there exist any negative numbers? Yeah, we have negative 3 multiplied with negative 3, that is also is equal to positive 9. So while opening a square root, there are always two possibilities, positive or negative. It can either be positive 3 or negative 3. Similarly, if someone asks us what is the square root of 16, we have positive 4 or negative 4. Similarly, for positive 25, we have positive 5 or negative 5. So we can see here we are basically dealing with positive numbers. So I have removed that negative part. So here it is 3, always it is plus or minus 3, here it is plus or minus 4, here it is plus or minus 1. Next, square root through repeated subtraction. It is a method of finding square root by repeated subtraction. For example, let me pick a number, the so called 9. What is the square root of 9? So I have 9, I am subtracting 9 with 1. So 9 minus 1, which is equal to 8. In the next term, I am subtracting with 1. Next one, I am 8 subtracting with 3. So 8 minus 3, which is 5. In next step, I am subtracting with 5. So we have 8 minus 5 minus 5, which is equal to 0. So you can see that 1, 3, 5, these are all consecutive odd numbers. So the method is we are subtracting the number with corresponding odd numbers. So if I subtracting with 1, then next I am going with 3, next I am going 5, next I am going to 7 and so on. So here we have to do until it reaches 0. So it is equal to 0. And the square root of this number, that will be number of times we are performing the operation. Here we have performed 3 times, 1, 2 and 3. So the square root of 9, that is equal to 3. Now similarly, we are going for the next one, which is equal to 16. So 16 minus 1, which is equal to 15. Next one, our next consecutive odd number. So that is after 1 we have 3. So 15 minus 3, which is equal to 12. And in the next one, after 3 we have 5. So 12 minus 5, which is equal to 7. And after 5 we have 7 as our odd number. So 7 minus 7, which is equal to 0. Now you can see the square root of 16. How many times we have performed the operation? So here it is 1, 2, 3, 4. So the square root of 16, that is equal to 4. We have 4. Okay, next one. Finding by prime factorization. The method of finding square roots by prime factorization. Suppose our number be equal to 576. So 576, that can be written as, it is nothing but 288 multiplied with 2. So the method is, I am picking the first number, so which is equal to 2. I am seeing whether it is divisible by 2 or not. 576 is a number which is divisible by 2. So we have 2 here, 2 multiplied with 2, which is 4. Here it is 5, so there will be a remainder of 1. So I am choosing that one to be here. So this 7 turns to be 17. 8 multiplied with 2, which is 16. Here it is 17. So again a remainder of 1 with 6. So it turns out to be 16. So 8 multiplied with 2, which is equal to 16. So our number is 288. In the next step, I am again dividing with 2. So with 2 here I have 1. Here 4 multiplied with 2, 8. Again 4 multiplied with 2 is 8. So 144. Again I am going for 2. Here we have 72 because 7 multiplied with 2, 14. 2 multiplied with 2, 4. Here we have 36. 3 multiplied with 2, 6. Here we have 7. There is a remainder 1. I am adding that 1 to this one. So this turns to be 12. So 6 multiplied with 2, which is 12. So 36. Next one I am going for 18. 18 multiplied with 2, which is equal to 36. Next one it is 9. Now we know that 2 is not divisible with 9, but in fact 3 is divisible with 9. So I have 3 multiplied with 3, which is equal to 9. And here comes the end. Now we can write this in such a form. We have 2 square multiplied with, again we have a 2 square multiplied with 2 square multiplied with 3 square, and I can group them. I'm always grouping with 2 as 1. If there is, see, I will show you. Here we have 2, I have written them in entire form. Now I can pick this 2, there is a 2 multiplied with 2, this is 1. Here also 2 multiplied with 2, this is also 1 pair. 2 multiplied with 2, this is 1 pair. 3 multiplied with 3, that is 1 pair. So from each pair I am picking 1. So here I have 2, this is a pair, this is a pair. Now I am picking 2. Here also we have a 2. There also a 2, and in next one we have 3. So the square root of this number is the number which gives us when multiplied this number. So 2 multiplied with 2 multiplied with 2 multiplied with 3, which is equal to 2 into 2 4, 8 into 3 24. So the square root of this number, that is equal to 24. This is the method by prime factorization. Next we can see for next one is 256 a perfect square. We can see check it by method of prime factorization. So 256. On division with 2 we have 128. Again on division with 2 we have 64. Again on division with 2 it is 32. It's divisible by 2, it's 16. Next it is 8. It is 4. It's 2. Now how many 2's are there? You can see 1, 2, 3, 4, 5, 6, 7. There are 8 2's. So we can pair them as such. So 2 square multiplied with 2 square multiplied with 2 square multiplied with 2 square. So on pairing we have 2 multiplied with 2 multiplied with 2 with 2. So we have 2 multiplied with 2 multiplied with 2 multiplied with 2, which is equal to 16. So the square root of 256, that is equal to 16. Okay, next one, it is a perfect square. The question was, is 256 a perfect square? Yes, it's a perfect square. Now find the smallest number by which 8820 must be multiplied to make a perfect square. So we need a number such that to make this one a perfect square. Of course, it's not a perfect square, but we need to see when we multiply with the smallest number, this one turns to be a perfect square. So we want to find that. For that, by prime factorization, I can write 8820 as 2 square multiplied with 3 square multiplied with 7 square multiplied with 5. So for this 5, we have 1 5. There is no enough sufficient for, I mean, there should exist at least 1 5. This 5 must be in the term of 5 square. So we have a 5 missing in this term. So if you multiply a 5 into this one, this turns to be a square number. So the least number that must be needed is 5. So we have, if you multiply a 5 with this one, it turns to be 5 square. Now we can combine the data and we can find what is the number. But the least number to be multiplied, that must be equal to 5. So the least number, that is basically 5.